Algebra 2 students, this video is all about going through the Quizziz problems you guys were assigned for homework and walking through them. So it's like an answer key in words, just so you can think through some ideas for problems that you might have had some trouble with when you were doing the homework. So the first one is log base 3 of 81. And remember, the big goal of this is just to get comfortable going back and forth and rewriting logs and exponentials. So log base 3 of 81 equals what? So remember, this is saying, if we think about that kind of circle method, 3 to what power is 81? So this is what it's saying in words. 3 to what power is 81? So when you evaluate a log or simplify it, it's always going to be equal to a specific number. It's equal to the power. So we're thinking 3 to what power is 81? That's what we're trying to think through. 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's going to be 3 to the 4th power. So your answer is just that 4. And as you can see, the other options were squared, cubed, or to the 5th power. Okay. Second one is taking 3 to the 4th equals 81 and writing it in log form. So the first one took log and we had to think about it using exponential ideas, right? These are saying the same things here. Okay, so we're thinking about it in a way that makes more sense to our heads, right? So 3 to the 4th power is 81. Remember, it's a little tricky knowing what number goes in the bottom. It's going to be the 3. And then if I want to think about the 81 is going to go here, and then it's going to be equal to, whatever number. We don't know what that number is, or actually, sorry, we do. It's the 4th power. I am having a moment. So it's 3 to the 4th power is 81. So this is a complete statement. Remember, it's always equal to the power. And another thing that might help you think through where other pieces go, 3 is the base being raised to a power. This is log base 3 of 81. So that also kind of helps to think through where things go. So it's always equal to the power. And the only reason we rewrite it with exponential form versus logs is reading this as 3 to what power is 81 and figuring out that it's 4. It's a little bit harder for us to think through that compared to here. We can see the relationship much more clearly. So these are both saying the same thing. Saying the same thing. I'm just going a little bit slower just for the first couple, and then I'll kind of go a little bit faster for the next couple. I just wanted to go over a couple of those big ideas, the first two. So rewrite log base p of t in exponential form, okay, equals m, right? So to go from log to exponential, we take our base and do our circle method. So p to the m power is equal to t. Right, so this is really about getting you comfortable writing in both forms. Remember, these are saying the same thing. These are equivalent statements. We're just thinking about it in a different way. Okay, next one is asking us log base 5 of 25 equals what? So remember, in words, this is saying 5 to what power is equal to 25. So writing it in the exponential way helps us think through the question that it's asking. And then the answer is your power. It's going to be the 2nd power. We need to square it. Continuing on to problem number 5. Problem number 5 is saying, okay, here's log form. And to write it in exponential form. Now remember, this is not saying anything different. It's just saying the same relationship, just in a different way. 6 squared is 36. Right? The log statement is saying 6 raised to what power is 36, and that's going to be a 2. So these are both saying the same thing, just in a slightly different way. And this really comes down to the fact that logs and exponentials are very intertwined, right? Like we saw, they're inverses. So that's why we studied them together, is because they're useful to learn as a pair. We're starting with exponential form, and we're rewriting it in log form. Remember, base is going to be the base of our log. So log base 6. And then the tricky thing is what goes here. It's going to be the number that you get as a result, and then the power is on the other side. So remember, log base 6. 6 is the base being raised to 3. That's how I always remember which number goes in the base. And then remember, if you need a double check, I like to do 6 cubed is 216. I do my circle method, and that's kind of my way to double check that I got it correctly. Okay, and then there's our answer, right? We're writing it in the other form. So we're just getting comfortable understanding how to read a log and think about it in a log way and in more of an exponential way. Number 7, the following can be written as, see, log base 2 of 16 equals 4. So it looks like our answer choices are kind of getting us to think about the exponential ideas, right? So 2 to the 4th power is 16. And that looks like it's that option D right there. Notice some of the other answer choices are getting the 16 and the 4 mixed up, right? Knowing which one goes where. So that's one of the things that they're thinking you might accidentally do. They're thinking that might be a common mistake. Number 8, we're rewriting 12 squared equals 144 in the log form. Remember, the base is 12, so 12 goes on the bottom. The resulting number is over here, and then the power is on the far side. So remember, oops, that's kind of hard to see. Sorry about that. Let me get a different color. Base of 12. 12 is the base being raised to the power. And then I like to do my double check with my circle. 12 squared equals 144. That's always how I double check. Okay, so these are saying the same thing, just in a different way. I like to think about logs more in terms of the exponential relationship that's going on there. Some of you guys may be able to do like 12 to what power is 144 a little bit easier. Kind of depends on how our brains work. We've got a true false. Log base 8 of 64 is equal to 2. Let's check it with the circle method. 8 squared is 64. That's true. Right? It's asking what power do I raise 8 to get to a 64. The power is equal to 2. Let's move on to number 10. Okay, number 10 says rewrite this in exponential form. So using our circle method, 2 to the 3rd power is 8. That would be switching from log to exponential. Hopefully at this point, once you've done, the first 10, you're kind of feeling better. You've kind of got through the newness of it, right? Number 11, 5 cubed is 125. Remember, the base, the number being raised is going to be our base here. The resulting answer, and then the power is on the other side. And you can always do your circle method to double check, right? That's always a good double check in my book. Number 12, rewrite this in exponential form. We are going to, do so many of these to feel comfortable going back and forth, right? Practice helps us feel better. V to the A power equals N is what we could say as another way to write it, right? They're equivalent methods of expressing the same idea. Number 13, log base 289 of 17 equals a half. This one might look a little bit weird to you. What this one is saying, if we think about our circle method, is 289 to the 1/2 power is equal to 17. So the question is, how do I shrink something, right? Raising it to a power. I'm going to do a quick calculator pull-up. And here is the calculator. You'll notice I did both to the power of 1/2 and the square root. Those both result in a 17. This really came back to our exponents unit. And one way that we saw how it works is we did 25 to the 1/2 power times 25 to the 1/2 power. Remember your exponent rules. If I do like 5 squared, or let's do a different number than 5. Let's do 7 squared times 7 to the 5th power. Remember, that's 2 7s times 5 more. That's 7 7s, or 7 to the 7th power. So remember, when we multiply with the same base being raised to powers, right, we can add the powers. That was one of our exponent rules we saw first semester. So if I do that, I would say, okay, I have the same base, right, and then I add the 2 and 5 to get 7. I add the 1 and 1/2 and 1/2. That gets me a sum of 1. So I'm saying something times itself gives me a 25, right? That means that this has to be the same thing as a 5. And that means it's the same thing as a square root of 25, right? The square root of 25 is 5. So that is how I originally introduced you guys to the 1/2 being the same thing as square rooting. Same kind of thing happens with cube ideas. If I do, oops, I gotta do this as a fraction to get it fully. If I do it to the 1/3 power, that's going to be the same thing as cube rooting the 27 to get a 3. So 1/4 power is like the 4th root, 1/5 power is the 5th root, and so on. So keep that in mind. We are now on number 14, it looks like. But I just wanted to weave in a little bit of exponent review, just to review. So notice this one is not asking us, a lot of the ones we've been looking at have been asking us to go back and forth between log and exponential. This one is saying to say what it's equal to. So remember, this is saying 4 to what power is 16, right? So 4 to what power is 16? You can think about it like that if you like the circle method. I normally put like a box. It's going to be 4 squared. That gets us a 16. So remember, when I write it like this, the answer is always the power. It looks like we are now on question 15. To rewrite this in logarithmic form, this is 9 to the 3 over 2 is equal to 27. Remember, we've got our, I did not switch the highlighter, we've got our base. So log base 9 of our result, 27, is equal to the power of 3 over 2. Right, notice, it keeps doing that to me. Notice base of 9, right? 9 to the 3 over 2 is equal to 27. Okay, so our final answer, remember they wanted us to rewrite this, so the answer is like the whole thing. We're just rewriting it in a new form. Number 16, we've got log base 7 of 1 over 49 is -2. And they want us to rewrite this in exponential form. So using my circle method, they're saying 7 to the -2 is 1 over 49. This is another good quick pause to review some negative exponent ideas. Remember, a negative exponent, I'm going to consider this as like the top of a fraction. It's like over 1. Negative exponent on top goes to the bottom. So it's going to become 7 squared. Notice the exponent changes from negative to positive. And then I want to write it as 1 on the top, right? Not a 0, because then the fraction's equal to 0. And then that's going to become 1 over 49. Okay. Some people also prefer to think about it like 7 over 1 to the -2nd, and think about it as you flip the fraction and then you square it. You can think about it in both of those ways, but this is really coming back to reviewing those negative exponent ideas we saw first semester. So trying to weave in some of those ideas. We've got just a couple more. Number 17, rewrite this in log form. Right? Remember, the base is 7. That's going to be the base here. The result is a 1, and the exponent is 0. As a double check, 7 to the 0 is 1. Remember, anything to the 0 power is 1. Remember, they asked us to rewrite it, so our final answer is like the whole thing. We are just writing it in a different form. Number 18, log base 4 of 1. Some of you guys were getting really creative in that celebrity hidden pictures puzzle. Figuring out the 1. Second period, we will be doing that as a quick warm-up since we ran out of time. So this is saying 4 to what power is equal to 1. A lot of you guys were getting quick at seeing the 0 power. And then number 19. Oops. Number 19. Number 19 is asking us to evaluate. So say what this is equal to, right? Sorry about that. My computer's lagging a little bit with the erasing. They want us to evaluate log base 6 of 1 over 36. This one's really good. So I'm saying 6 to what power is 1 over 36, right? 6 to what power is 1 over 36. Anytime you raise something to a power and you get a fraction, right, that should be your Q. It's going to be a negative exponent. It would be a -2 that this is equal to, because you need to square the 6 to make it 36, and the negative flips it. Okay, and then final one, we are evaluating, this is for number 20, log base 4 of 16. It's saying 4 to what power is equal to 16? It's going to be 4 squared. And that is it for our Quizziz review. Okay, hope that helps. We are going to do some more practicing with exponentials and logs on Tuesday, so I'll see you guys then.